Okay, welcome back everybody. We're going to look at rationalizing denominators here. And we're going to be skipping quite a bit of the textbook here, so I'm just going to attempt to streamline this to make for a little bit less work for everybody. And so this is going to be part 1 of rationalizing denominators. Rationalizing denominators, and it's just like it sounds. Okay, we don't want irrational numbers in the denominators, so we do something called rationalizing them. Okay, now before we begin here, I'm just going to remind you of a quick property. And you've been using it all along here, but we're just going to state it explicitly here, just to remind people. Okay, so the property is this. The square root of a times the square root of a equals, well, we all remember, if I'm recombining the radicals here, I do a times a, which is a squared, and then, of course, the square root of a squared is just a like so. Okay? All right, so we're going to use this to rationalize denominators. And it's fairly simple. And so, for example, let's rationalize. Let's rationalize 5 over the square root of 2. All right, so all we need to do here, okay, we've got an irrational number in the denominator. Square root of 2 is an irrational number. So what we're going to do is just multiply the top and bottom by the square root of 2. Like so. We just want to get rid of the irrational numbers in the denominator, and how am I going to do that? Well, I'm just going to multiply the top and bottom by the square root of 2. And, of course, the square root of 2 divided by the square root of 2 is just 1. Anything divided by itself is 1, so we haven't changed the value of this expression at all. And then what do we get after we do that? Well, I just get 5 times the square root of 2, which is 5 root 2, divided by, well, the square root of 2 times the square root of 2, well, that's the square root of 2 squared, or the square root of 4. And the square root of 4 is just 2. And that's why I wrote this property right here. Okay, so the square root of 2 times the square root of 2 is just 2. Okay, and that's all there is to this question. All right, let's try this again. Okay, let's rationalize. Let's do the square root of 6 divided by the square root of 3. Okay, good. Well, again, this one's pretty straightforward. There's going to be a little bit of extra work at the end, but we can get started right off the bat by multiplying the top and bottom by the square root of 3 like that. Okay, now when I multiply this times this, the square root of 3 times the square root of 3, that's just 3. Okay, now when I do it in the numerator, remember, we can combine the radicands together. So this is actually the square root of 6 times the square root of 3 is the square root of 6 times 3, which is the square root of 18. Okay, and now as a last step, we should simplify the square root of 18. Okay, so if we just do that off to the side here, what do we get? The square root of 18 is equal to the square root of 9 times 2, and I could break that into 2 separate radicals, but altogether I get the square root of 9 is 3 times the square root of 2, like so. Okay, so our final answer over here is 3 root 2 divided by 2. Divided by 3. Just noticing that altogether in this question, what's going to happen here now? Well, now we can cancel common factors, and we're just left with the square root of 2. I was just thinking in my head, well, we could actually go a different way here. I could combine these and make them into one radical, and then 6 the square root of 6 divided by 3, but anyways, that's for another time. Okay, we're not going to do it that way. All right, let's talk about how to rationalize denominators for this type in general. Okay, so to rationalize, okay, the first thing we're going to do is just simplify each radical right off the bat. And then 2, we're going to perform the rationalization step. And we're going to rationalize. And then 3, we're just going to simplify each radical again, if necessary. Okay, let's do an example here. Okay, let's simplify, or sorry, rationalize the square root of 18y cubed divided by 4 times the square root of 4x. Okay, well, the first thing I would do here is simplify this radical and simplify this radical. Maybe I would just do this off to the side. Well, let's do it here. Okay, so let's start with the square root of 4x, because that one's easy. Square root of 4x, well, of course, that's just equal to the square root of 4 times the square root of x. And then from there, square root of 4 is 2 root x. Okay, so I'm just going to replace that with 2 root x. Okay, now if we do the square root of 18y cubed, okay, well, this equals, okay, 18 is the same as 9 times 2. I'm just going to order this right off the bat, perhaps convince yourselves. I'm just putting the perfect squares at the front. And so again, 18 is 9 times 2, and y cubed is y squared times 2y. And then you could break these into separate radicals. This is the square root of 9 times the square root of y squared times the square root of 2y. And then the square root of 9 is just 3. Square root of y squared is y times the square root of 2y. Okay, so we'll replace this with that. Okay? All right, let's try this out. So what do we get all together? Okay, I've got square root of 18y cubed over 4 times the square root of 4x. Well, this just equals, I'm going to replace that with that, 3y times the square root of 2y divided by 4, and again, I'm just replacing the square root of 4x with 2 root x times 2 root x. Okay, and I'll take another moment to simplify this, or another step to simplify this. This gives me 3y times the square root of 2y. I'm just going to multiply the 4 and the 2 together. 4 times 2 is 8 root x. Okay, good. All right, so now the last thing to do here is just rationalize. So I'm going to multiply the top and bottom by the square root of x over the square root of x like that. And this leaves me with 3y. Now I can multiply the insides of these two radicals together. So I just get the square root of 2 times x times y after I reorder it. And then root x times root x is just x. And I still have the 8. And we're done. Okay, good. I think that's about it for this video. So that's just a really quick video on how to rationalize denominators. We're going to practice more on the second type. Okay, bye for now.